And before lunch, I want to remind you to stay in the room to again play the interactive game from yesterday. And now I welcome Huang Hu, who is presenting the last talk of that session. Shohei, who is presenting LiveSphere.
So thank you for introduction. So hello, I'm Shohei Nagai from the University of Tokyo. Today I will introduce my system called LiveSphere. So LiveSphere is a system for sharing the environment and with remote person and realizing effective remote collaboration. So let's start with background and goal of this research. So in collaborative work, sharing visual information with each other is important to realize effective collaboration. And the wearable camera can capture the environment around the wearer. So using net, one person can share the environment anywhere, and the remote person can give guidance on the introduction by the information. But there are some problems when using wearable camera to share the environment. So this video is captured by wearable head-mounted camera. As you can see, a video from wearable camera is always shaky due to wearer's head motion. So it might cause motion sickness. Moreover, the view is limited by wearer's head orientation. So the viewer is constrained to look at the wearer's focus of attention. And they must reorient as the wearer moves along the workspace. This makes it difficult to understand the situation and prevent effective remote collaboration. So such problems occur because wearable camera capture only a part of environment, and the view is limited by wearer's head orientation. In short, the view is dependent on the wearer's head motion. So our goal of this research is for effective remote collaboration, sharing four visuals surrounding one person with a remote person, and provide independent view from the wearer's head motion in the shared environment. This will realize deep understanding of the environment and effective collaboration. So how can LiveSphere share environment surrounding one person and realize independent view? LiveSphere does two things to realize that. First is capture four visual space using omnidirectional camera. And second is decouple head motion from the view using the wearer's head motion captured by motion sensor. Through this process, a person can share the surrounding environment with a remote person. So this is the system overview of LiveSphere. A person in an actual workspace where head-mounted display and device to capture the surrounding environment and share it with a remote person. The remote person observes the shared environment using head-mounted display. And voice communication is available in LiveSphere. So as a definition, here we define a person who works in actual place and shares the environment as body user, and a person who is in remote place and observes shared environment and give assistance and guidance as ghost user. So this is the image how LiveSphere works. Bodies share the environment with ghost, and ghost user observe the shared environment independently from body's head motion using head-mounted display. Through such interaction, LiveSphere have many possible applications. in sports activity, LiveSphere can share the experience with Ghost, and Ghost can give some instruction for body. Or disaster rescue is one possible application. By sharing the environment, our body and Ghost can cooperate to search and rescue refugees. An experience of shopping together and introduction of DIY is other possible applications. So from now, I will explain about the system implementation. So first, explain a body user part. So this is a head-mounted device called Headgear. Headgear has 6 wide-angle cameras. Each camera is directed towards the outside to capture 4 visual space. And Headgear also has motion sensor to capture body's head motion. This is used when decoupling head motion from the view. So body wears Headgear when collaborating with Ghost. So here, LiveSphere captures 4 visual space in body's environment using Headgear. So in LiveSphere, the 4 visual space is recorded in the form of spherical image. We use equirectangular projection to map 3D visual space to 2D image. This projection is often used in WorldMap. And that Headgear's 6 camera provides 6 video image, and then 6 images are stitching into spherical image through a rectangular projection using GPU in real time. So through this process, a LiveSphere records the 4 visual space surrounding body user as a spherical image in real time, like that. And simultaneously, Headgear captures the body's head motion using motion sensor. And this data will be used for decoupling body's head motion from the view. And then the recorded spherical images and rotation data are transmitted using the internet to Ghost user. So next, explain Ghost user part. In Ghost user part, LiveSphere provides a view in the shared environment with Ghost. In Ghost part, the shared spherical image are mapped on the virtual sphere on 3D graphical world. And rendering camera located in the center in the sphere capture its view as Ghost user's view. So this is the view shown to Ghost user so far. And here, the view still include body user's head motion. This makes it difficult to observe the environment and cause some problem in remote collaboration. So here, LiveSphere decoupled body's head motion from Ghost's view. So using rotation data of body's head motion transmitted with spherical image, a LiveSphere rotates the mapped sphere as much as the head motion. So through this, the head motion in the view is stabilized and the motion is decoupled from the view, right image. And moreover, a LiveSphere shows the head orientation in Ghost view. This is useful to understand what Ghosts see and their focus of attention, and that leads to effective communication. So this is actual view of Ghost user. A LiveSphere stabilizes the rotation and provides the view decoupled with body's head motion like this. And LiveSphere also uses Oculus Rift as head-mounted display to show a view to a ghost. Oculus Rift captures the head motion and provides a view synchronized with the motion. So ghost user can observe the environment as if he is actually there. So this is actual view image provided by Oculus Rift. A ghost user can see the environment on any direction by moving his head. So through all this process, LiveSphere provides an independent view from body to ghost. This video shows the example of remote collaboration using LiveSphere. In this video, body is looking for a book, and ghost observes the body's environment even on different direction from body's head, and teach the place of book, and body can find it. So conclusion, LiveSphere share environment for remote collaboration. This includes two parts: to capture full visual space and to decouple body's head motion from the view. Through this, LiveSphere provides the independent view from body's head motion and realize effective remote collaboration. Thank you for listening.
Thanks, really cool work. So there's already a question.
Thank you very much for the beautiful implementation of shared view. And towards design of shared environment, also how to let people share, manipulate, and also edit or restructure the objects. Objects can be also virtuals or physical stuff. So do you have any thoughts how you may extend this shared viewing system to the real shared manipulative space, including how to coordinate all the conflicting interaction? This is an open question, but I'm very much interested in hearing your opinions.
Oh, it's a good question. Actually, I think one way is some projection, using some light or projection the real world and indicate what the body should do.
Mm-hmm.
So I think the solution is instruct body and do actually by body.
I think there are maybe several steps. First,
yes.
How to refer point, verbally, gaze, or finger, or arm.
Okay.
Second, how to annotate on top of the existing stuff. Yes. Third, how to let people manipulate, maybe move, transform, or whatever. But then next, more internal like editing. So there are many different layers of the shared manipulation. So I hope you can tackle them present in next TEI conference. Yeah. Thank you.
Thank you.
Very nice piece of work. My question is really simple, which is my experience of Oculus Rift is I get motion sickness. So the question is, when someone else is providing it for you, do you get greater or less motion sickness in Oculus Rift through your system?
Yeah, actually, I made a user study, and by using this system, motion sickness is improved.
It's better or less?
Yes.
Okay. I'll have a go on your system then.
I may have missed this point in the talk, so forgive me if I did, but you seem to have done a pretty good job working out the problem of decoupling rotation of the head. But I didn't see any evidence of decoupling or figuring out how to deal with the translational problem, right? So if I'm walking through the space and the ghost is riding on my head and they're looking over here and I'm looking there, do they get whiplash when all of a sudden I turn a corner? Or have you experimented with that yet? And how's it been?
Yeah, I think it is an issue I have to work for. But I think Wearable camera is merit is capture the environment in the same place of the wearer. So translation is in the case, it is not important. So the same point or same place is important.
Well, it's not important if we're doing a task in one location, but it becomes important if, say, you're giving me a walking tour of the space, doesn't it?
So, actually, by this system, it is difficult to deal with translation. So if I realize that, I have to some robot or something like that.
Okay, thank you.
Yeah.
Last question. Did you try being the body and the ghost the same person? So did you walk around with the system, kind of trying sensory augmentation and have a 360 view? Did you try that?
Augmentation?
If you are wearing the cameras and the glasses.
Actually, previous project I use are augmented reality, but in this system, I don't use it, but I want to try it.
Cool. Yeah. Okay, so let's thank the speaker and the speakers of the session of making connections.